Alright, so this video is going to go into slightly more detail uh, into the assignments that we're going to be dealing with. So, first assignment, interpreting plans. This assignment came to be because Dr. Sukumaran, who was the chair before Dr. Jahan, said that Rowan students weren't doing great in terms of interpreting plans. And that was before I was teaching, stuff like that. So I decided to come up with this where I took some drawings from some of the stuff I've worked on, and we're going to try and comb through it and pick out details that we need. So it's like, oh, that's what this is saying. This is what this is trying to say, so on and so forth. And then also the whole 33 demos and then 6 other demos thing. You learn to read and understand what the drawings asking for. So I think those combined, I haven't heard any complaints since about issues interpreting plans where it could be improved. So I think we're doing a pretty solid job. But this says consult assignment 1A, 1B, and 1C PDFs and answer the questions in the assignment 1 Word file. There are 2 places that you may end up finding resources for assignments. One is in a folder that I will have sent you that says additional homework files. The other is at the end of this document in the additional resources section. The assignment itself will tell you specifically where to find it. So if it says in the additional resources page, that means it's in this syllabus document. Otherwise, it's going to be in the in that folder. So consult 1A, 1B, 1C PDFs. All right. We could see we have 1A, 1B, 1C. It also says to open up the Word file for interpreting plans. So we'll see that it's 5 questions. Interpreting plans, name. So, first question. What is the length and width of runway 826 at South Jersey Regional Airport? 2. What's the true bearing, South Jersey Regional Airport? What is the proposed asphalt surface for the normal section? So this one seems a little different. It's not talking about a runway. It's not talking about that airport. What's the scale associated with the typical section for Route 1? So it seems like these may be related since they're both Route 1. According to the sinkhole restoration detail, what would be an acceptable compaction lift thickness? Okay. So let's try and find the answer for this first one. What is the length and width of runway 826 at South Jersey Regional Airport? Let us open up one of these PDFs. Assignment 1A. Okay. So just looking at this, it looks like you have some type of construction trench, and it's talking about removing material, existing subgrade, what you're backfilling it with. This looks like certain pavement material, and it's talking about an existing pavement. And if we look down here to the bottom right, it says sinkhole restoration detail. That should click in your head, because I mentioned those words specifically in one of the questions. It's not specifically question 1, because it's not South Jersey Regional Airport. It doesn't seem like, at least it may be in here, but it does not seem like it. But down here it says according to the sinkhole restoration detail. So essentially what you're going to do is be going to this drawing to answer this question. And I need you to comb through it and think. Some of these are just, oh, I found it on the plan, that's the answer. Some of these are, oh, this plan said this and that you have to do this. So some of these questions are 2 to 3 step, and some of them are just, oh, I found it, here's the answer. But that's essentially all you're going to do for that assignment, is open up these different PDFs and find the answer. Okay, so we could close that one. Assignment 2. AutoCAD sketch of BP33. So we're going to recreate the 3-view and section AA drawing of BP33 as shown in the additional resources section. So that tells you to go down here to the additional resources section, 3 view drawing of BP33 and the section AA. We are recreating these drawings. So we are going to do those at some point. And if you had taken CAD before, your first instinct is going to be, oh, I need to draw this in 3D, which is this, and then I'm going to need 3 different viewports to show the top, front, and left side of this drawing, and do that. No, this assignment is purely 2D. So what we are going to do for this is just draw this in 2D with all the dimensions and that, with the different line types, and just recreate it. And then this will be a separate drawing as well, which is actually just like a mirror image of this. But for this one, if you've never seen a 3-view drawing before, these line up. So if we drew a vertical line here, the left edge of this will line up with the left edge of this, because it's showing you the same thing. And then similar down here, the bottom of this and the top of this will line up with that. And the thought of this is, if you trying to find something that I could use to represent this around me, but I don't have it. But essentially what happens is this drawing, if you were to fold this paper along this line right here that I'm drawing on the screen, which I hope you could see my cursor, but essentially it's between the 2 bottom pictures and the top one. If you drew a horizontal line across that and you were to fold the paper on top of itself, you would be able to be like, oh, if I was looking at this object from the top and the front, that's what it looks like. And the reason you have these dashed lines is because when you're looking at the front, you have no idea that there's some type of notch right here. You would just assume it's solid unless you had that. And then similarly, if you drew a vertical line between the 2 drawings on the left and the one on the right, and you were to fold it that way, that's your side view. So if you fold this paper down on itself and over, you got all 3 views of this drawing right here. So you could see, if you looked at this drawing, this front view looks the same as this bottom left one. That's what it will look like if you were just looking at it straight on. And if you were looking at it from the top, it's going to be kind of this oval, elliptical-ish shape, or curved rectangle, whatever you want to do. With this, it's going to end up looking like a rectangle, because the circle from the top just looks like a rectangle because you just have 2 defined edges. And that's where this is coming from. So we're just going to end up recreating this drawing where you have like 2 over, 4.5 over, so on and so forth. Follow it over, boop, boop. And we'll end up making these curved. And we're essentially just going to end up recreating this drawing. So you could see I now have like the start of the outside of this top drawing. Then we'll eventually draw the notch, and then towards the end we'll end up dimensioning it. But that's what assignment 2 is. It's just recreating this in 2D fashion. All right, assignment 3. Site plan. Recreate the site plan shown in the additional resources page. So again, that's in this document. We're going to be drawing stuff to exact lengths and bearings. So unless there is a dimension error in the figure, blah, 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 tells you how to enter a degree symbol. Also include a north arrow, which is not shown on the plan, but I want you to include it. So essentially for this assignment, we are redrawing this. This drawing here, we are redrawing. And it also wants you to add a north arrow. For this one, we're going to end up having to change our angle type to surveyor's units because it's specifically talking about bearings, which one of my presentations will go over bearings and azimuths and stuff like that. But all you need to know is this, like this north 1 degree, 53 minutes, 46 seconds east. That is the typical nomenclature for a bearing. A north or south direction and an east or west direction and a certain angle. When we change our units, which in CAD you just type in units and it pops up this dialog box, you could change decimal degrees to surveyor's units, which you can see down here ends up being a bearing. The precision, I'll end up matching this document. This is just for display purposes, but it looks like it goes to this one. So you have a degree, 2 different minutes, 2 different seconds with no decimal points, so we could go with that one. Engineering units just means we could have it in feet and inches. Disregard this. This has nothing to do with what we're doing. So don't change this to feet and then think if you typed in 111.44, it's just going to work. Disregard this. Engineering, surveyors, units, okay. Now, I'm going to pull up a website just so you could specifically see the nomenclature, because it's very picky on how you insert it into into AutoCAD. So if we end up going to this, we have entering bearings in AutoCAD. If you just type that into Google, the one I generally go to is this because it bolds exactly what you need. It'll end up coming to this website. This is the specific nomenclature you need to enter in a bearing. An @ sign, a specific length. For our purposes, we're going to have to put an apostrophe on this to get the feet symbol on it. And then a less than sign and then the bearing. So let's situate our thing so you could see the nomenclature. Okay. Let's just try and do this line. You can see the nomenclature and CAD. Okay, so we are going to draw this line right here, this 110.53 foot at north 1 degree, 53 minutes, 46 seconds east. So this line right here, we are going to draw. So the way you do that is you start your line command, enter, and you specify a point. Now this is where we will be following this here. So if we do an @ symbol, we will do 110.53. Don't forget the apostrophe because that says that it's going to be 110.53 feet. Oh, thank goodness my video is not in front of that nomenclature. Cool. 110.53 feet. Then we do a less than sign. You'll see that it brought us to the right part of it, which is where we enter in our bearing. So for this, it's going to be north, 01D, 53 apostrophe for minutes, 46 quotation for seconds east. And it drew our line 110 feet at that angle. And you could double check this by going to the properties. Hello, doggos. By going in here, and you could see that it says north 1D, 53 minutes, 46 seconds east. There is one thing you have to be careful about. These angles are relative to where the line started to be drawn from. So if you were to look at this line here, if you were trying to draw this 131.27 line from this point, you're going to have to invert these directions. So I don't need this anymore. You would have to invert these directions because you could clearly see that this line is going down and right, which would be south and east. So if you're drawing it starting from this point and going that way, you're going to have to keep this same angle, the 88 degrees, 13 minutes, 4 seconds, but you're going to have to say southeast instead of northwest. Now, if you're drilling it from the point that connects the 131.27 and the 73 line, that node, then you could type it in as northwest. Let me just demonstrate this real quick for you. So we drew this 110.53 line, and if we're drilling it from here, if I type this, let's actually draw the 73 line because it's going to end up going the wrong way, and I want to show you it going the wrong way. So we're going to start the line. We're going to do an @ symbol, 73 feet, less than sign, and if we just type in that angle as is, it's going to go up and to the left when we want it to go down and to the right. So north, 88D, 13 feet, 4 seconds, west. Now when I push enter, it's going to go up and left, which is not the line we wanted. We wanted it to go down this way. 2 fixes to this. You could either move it with M enter for move and move it over there, and now you're good. That's fine. The other way to do it is if you just started your line and you did the at 73 feet less than, and you're like, oh, this is going down and right. Clearly I need to invert the direction. So we'll go south 88D, 13 minutes, 4 seconds, east. Now you'll see that it actually went the correct way. And you'll see these lines are exactly the same. So however you want to fix it, if you screw it up or if you don't screw it up, is fine with me. But then eventually you're going to put all these text boxes in. So you'll do a text box and you'll just type in, let's say one of these was 80.0 feet. You'll see it gets very tiny. It disappears. It's there. We just got to change the text height. I think, if I remember correctly, 5 feet's a good thing. So if you go into the properties of this, oops, wrong one. If you go into the properties of this, you could change the text height. It was originally 0.02 inches. I changed it to 5 feet. And you could see it ends up looking good for this assignment. To do the text, all I did was type an M text and then type something. Again, this one's going to be small. You could see the text height is 0.2 inches, where this one is now 5 feet. You could change these in 2 different ways. If you wanted to, you could do the painter command or match prop. And if you click on this one and then you find that text, you can do that and fix it. Or when you're creating these, you could just do a copy, CO for copy, enter, click it, and you could just end up adjusting these and typing in whatever you want. However you want to do it, your prerogative. I'll eventually show you how to use annotative scaling, which will automatically scale this based on your the size that you're going to use in your viewport. But this is the quick and dirty way to get through with that. The nodes could just be made by doing a circle. You could just make a circle with C, enter, and make a little node. That should be it for that assignment. Okay, let's close that one. Site plan, horizontal alignment. Draw a road, horizontal alignment in AutoCAD named horizontal alignment. So that's going to be in the folder, horizontal alignment. Whatever. So you have this drawing. Draw a road in that file. The road is 40 feet wide. The new road center line starts at the center line of Beaver Creek Road at a point 900 feet west of the east edge. So you can see this is the center line of Beaver Creek Road, this line. And it's saying you're going to draw a road that's 40 feet wide starting from the east edge, so over here, a certain distance over, So essentially you're going to draw some type of road going over this way, about 900 feet. You could type it in. And then it says it has a bearing due north, certain point. I think it's like 350 feet, so probably somewhere in this area. And then it has a bearing north 30 degrees east. So the site plan assignment, you should be real good at drawing roads at a certain angle. But essentially all it's saying is this road's going to go off this way and at that specific angle. And I want you to create it. So you could end up creating the road. It says it's 40 feet wide, so you know you could offset it 20 feet in both directions. And then you could end up curving it using a fillet tool. It says the radius is 400 feet. And you're going to end up having this drawing where you're creating some road going that direction. And then you'll make it look prettier. Like you don't specifically need like this white line that was just used to get to this point to draw it. You'll get rid of that. It's telling you that painter command that I just taught you can be used to nope, over here, can be used to copy this line type to this line type to make it that green dashed. It says it wants you to, there are specific steps you need to follow through on this. It wants you to add a name to the road. It wants you to make the road lines heavier than the contour lines. So all these things that are on here are contour lines. So it just wants you to make these thicker. So if we go to line weight, you could change line weights of things, or you could go into the thing itself, properties, and this one down here, you could make things thicker or thinner, however big you want to make it. But you'll do that for the entire thing. And then you'll end up putting it on the title block that I gave you. Don't use the one that's here. You'll want to add the one that documents Brown University, Engineering Graphics, Code Edition, title block. Okay, so now we have added in our title block. And if you type zoom all, our drawing will come up. By doing that, I activated this viewport. And then you'll fill out all of this stuff down here. Your name, date, this is assignment 4, whatever scale you use. So I think it says to use the 1 to 200 scale. So you're probably going to have to create that. So if you go to custom, add 1 inch equals 200 feet. Now you can't just do 1 to 200. You're going to have to convert this to inches. So it's the same thing. So that'll be times 12, which is 2400. And then we could select this. You'll write whatever the scale is down here. Sheet 1 of 1. I went over that real quick, so let me go over that one more time. You're going to insert the title block that I have provided for you for your drawings. So if you go down here, this is your model space, which I'll go over in another presentation. This is your paper space. This is your viewport. You right click on one of your paper spaces from template. You find the file that I gave you. So mine specifically is in COVID edition of my file, and you could find your title block and push open and OK, and it pops up a new one down here. And what you end up doing is this is a window into your model space. So if we just type zoom all, our picture will show up so we could see it when this is active, and you can tell it's active by the outside border being bold. And then we can mess with the scale if we want. I had to specifically add a scale since I didn't have 1 inch equals 200 feet, like the assignment says. So the way I did that was I went to custom, I added one. This is just a name. You could say it, Professor Tomlinson is the worst. I hate him so much. And that's your name. But as long as this is what the scale needs to be, so that 1 inch equals 200 feet, that in CAD terms is 1 to 2400, because you need these units to be the same. So all I'm doing is converting 200 feet to inches, which is times 12, which is 2400. And then you just set it to that scale. So that's that assignment. Okay, so close that. No, we can leave that open. Next one says road profile. Draw the profile of the road in the road profile. That's going to be in the folder as well. Open up road profile. You are given this. So, for this, you have two views here. This top one is a top view of the drawing. So you'll see you have a plan view and a profile view that it's calling it. This would be called the plan view. This is the profile. What we are doing is we are creating an image to show the curve, the vertical curvature of this road as it goes from this left side to this right side. They're proposing a road. All these lines are contour lines, which are elevations. So you see there's 450 and 425, and these are equally spaced by 5-foot increments. So this is 430, 435, 440, 445, 450. This will be 455. Out here somewhere will be 460, and this is 420. So what we need to do is create a little profile of this road. But here's the issue. When we have a road, a lot of times it's kind of indetectable how much you're going up or down. So in order to visually see this in terms of a drawing, we have to exaggerate a scale. And it's likely that one of the student presentations will go over this, but I'm going to quickly explain it here. So you will exaggerate your vertical scale. Typical common ones are by 5 or 10 times. So as you're going over this large span of road, say you're going 100 feet, 200 feet, whatever it is, you may only go down a couple of inches or whatever, or a couple of feet. We're going to show that rate of change on a greater magnitude so you could see it in this drawing down here. So if we chose to use a 10 times exaggerated scale, for each foot we go down per scale for the assignment, we're actually going to represent it as 10 feet. So the way we're going to do that is this bottom one down here. If you did offset 10 feet and you just went and offset this a whole bunch of times, it seems small. Offset 10 feet. Oh, my bad. That would be for each foot. However, since we are doing 5-foot contours, I'm going to offset this 50 feet because I'm using a 10 times exaggerated scale, but I'm representing 5 feet. So 5 times 10 is 50 feet. And you'll see in a sec when I put labels on the y-axis. I was wondering why that looks so tiny. I'm like, this doesn't make sense. All right, so we created these. Where this crosses the y-intersect, we're going to end up putting the elevations. So we know this drawing goes from 420 somewhere up to like 460 because this is 455, This is 455. And this road continues past 455, so it goes to 460 somewhere. So if we just start this, we could do an mtext. This bottom one, we could call 420. And if we were to copy this a whole bunch of times, I'm just going to go every 10 because this font's kind of big. So it looks a little cleaner. And if we go 430, 440, 450, 460. So this line is 420, this is 425, 430, so on and so forth. That's the elevation of the proposed road. And then all you got to do is play glorified connect the dots. At this point, this road center line clearly crosses at 455. So you're going to draw a line down to 455. You're going to do this for each intersection. Now, some of these doesn't have a specific point, but you can kind of eyeball it. So you can see that's around there. That's 445. So we'll go down to 445. You're going to do this for each intersection. So you should have a line here, here, so on and so forth. And eventually what you're going to have is, this is 450. You're going to have some curve, which it tells you to use a spline command to play glorify connect the dots on all these specific elevations. And it's going to look something roughly like this, since I'm not doing each of the points. Yours is going to look slightly different, and then when you're done, you push enter at the end. And this is your vertical curvature of this road. And if we had not exaggerated it, this is 1 line, 2 line, 3 line, 4 line, 5 lines. This whole distance would be 5 feet. But since we exaggerated it, so 5 feet, this entire profile curve would have fell somewhere in between these two lines. Half of it, actually, had we not exaggerated it, which would be almost imperceptible to your eye. And then it tells you to do some other things. So just read these directions. It says in your title block, you're going to put as noted. So it's saying you're going to put as noted here. And the reason you have to do that is because you've exaggerated this scale. Like, you're actually going to set this drawing to 1 inch equals 400 feet, which will be this. Something around there. So the scale is actually 1 inch equals 400 feet, but you're going to put as noted here because you have to visually indicate that this is a scale of 1 inch equals 400 feet, but this one has a vertical exaggeration. And depending on what you used, if you used 1 inch equals 10 feet, so you could say, if you exaggerated it 10 times, you would say 1 inch equals 40 feet, or if you exaggerated it 5 times, you would say 1 inch equals 80 feet. Or you could say vertical scale 10 times exaggerated, something along those lines that indicate that you adjusted this and that you can't just take a ruler and say 1 inch equals 400 feet. Then it says to do a couple of other things. So just follow those directions. Assignment 6, floor plan for house. Create a floor plan, minimum 2 floors. This is going to be used as a basis for your final project. Your final project, it could be whatever you want. If you want to do your parents' house, if you want to do something that you've wanted to design before, if you like some show and you want to recreate their house, any of that is fair game. What I want you to do is draw the floor plan of that. So I'm sure if you live on campus, they had a floor plan showing it's like, hey, this is a 7 by 10 room, this is a 15 by 20 room, whatever. And that was a floor plan. You're essentially creating that. So, and I want you to add some 2D blocks. So essentially what you're going to do, this is just a sample one that I did. And it's going to be slightly tweaked because what I ended up doing just as a sample one was I took my 3D house and I just went on a top view. So you'll see there's some overlap in some lines, and that's just because it's 3D. Like this staircase kind of goes over, but that's because it goes over this closet. So there are certain things, but you'll see that the walls have thickness, so you have an outer edge and an inner edge. So you could use something 4 inches, 6 inches, however much. You could look at the walls in your house if you want, maybe somewhere around 6 inches. And you'll create your rooms and you'll offset these lines and you'll make sure that, say you're doing, let's just say our house is some type of box. You offset it 6 inches in. I clearly made a really big ass house. But the main thing I want you to note is these intersections should be trimmed out. So you need to make sure that that looks like that. And then what you're going to end up doing is you're going to create your rooms. There's going to be 2 different floors. See, there's 2 different floors. And you could insert different blocks into this using the Design Center. So if you type in AD Center for AutoCAD Design Center, or at least that's what I assume it is, and the easiest way to get to this, because yours probably won't just open to it, if we push the home button, we're going to go to ENUS. We're going to go to Design Center. And then if you go over here and you bust down the navigation tree on Design Center, you have all these different things. So House Designer, Home Space Planner, those will be some good ones to look through. If we open up this and we go to blocks, you could see now I have tubs. I got toilets and stuff like that. This is the floor plan. Most of your stuff should be from a top view, so you shouldn't be giving me this front view of a toilet because that would look weird from this. You would want like a top view of a toilet. And you can double click on it, push OK. And the whole reason this toilet looks super tiny is because I probably made a ginormous house. Yeah, I made that 120 feet. So this is to scale. This is correctly to scale. It's just that this is a McMansion. And you could add in all these different things you want by double clicking and going into them. And put them in your house. And that's essentially that assignment. Okay, so next one, assignment 7. Front and side elevation of your house. If you essentially go to the Google machine and you were to type elevation, drawing, house, CAD, something along those lines, images. Let's look for one that we kind of... Here, this one's simple. You're essentially going to be drawing something along these lines, but the assignment says create a front and side elevation, find example drawings. All I care about is that you give me a front. So the front of your house, wherever the door is, windows. So say it's this one, since this has a front door. This looks like a back door. I just need a front view and one of the side views. I don't need all 4, just a front and a side. And it should look something along these lines. But it's going to be whatever your house is. So if you want it to have square roof or a pitched roof, if you want your door to be in this specific spot, but once you're done with your floor plan, you should know exactly where your doors are going to be. And you should be able to use that as a guide for doing it. So that's what that one is. And then, as with all of your assignments, Like if it's a AutoCAD drawing, all of your drawings must contain a name, assignment number, date, proper scale, and sheet number. So every time it should be in the title block that I gave you, scaled to something that's not silly, which is one of the presentations that I give. So maybe a 16th will work for this. So that fits it pretty well, the entire house. And you'd end up putting that in the scale. 1/16 inch equals 1 foot. You'd put that there and you'd fill out the rest. So that's what we'd be doing for that. So every drawing should have that. Contour drawing. Again, one of the student presentations will end up doing this. And if you have Eric, I believe he relies on me to kind of teach this as your surveying professor. He'll be like, oh, Tomlinson will teach you. This is the assignment he's talking about, because he likes to rely on me. So one of your assignments in surveying, I believe, is you go out to like the field at Rowan, and like every 10 feet or whatever, you're going to take an elevation with the rod and level. And you're going to do this grid survey. So every 10 feet in each direction, you're going to get an elevation. That's what has happened here. So whether or not this is every 10 feet or 100 feet or whatever, they got an elevation. So this corner is 594 feet, 565, 534. This point is 563, so on and so forth. You have all these elevations. We need to create a contour map. So this is saying to draw 20-foot contour lines using splines. And it tells you certain things, like streams make contours like a V, while ridges make contours like a U. And where two streams come together, it kind of makes like an M shape. It tells you there's a summit at a specific place, B300, which is B300. So you know you got a summit here. I want you to add a road that connects H0 to H600 and then goes off to 1050, which honestly we should change that. I'm changing that now before I send it to you. 1200. So it goes off the map. No, that has to stay what it is. But you could continue on that line. So you could kind of continue it this way if you want to continue it off the rest of the screen. And we're just going to use linear interpolation for known elevations. So we know we have a summit here. So this 648 is the highest elevation on this map. We could see somewhere down here goes down to 359. So what we are going to do is create contour lines. Since we know there's a summit here and this is the highest point, I suggest starting at 640 because 648 is the highest, so we'll do 640, 620, 600, so on and so forth. So if we do spline, this point right here is 600 and this point right here is 648, which means we know 640 is somewhere around like here. And then we need to look for the next 640 line. If we go up here, 640 does not cross in between 595 and 600. The only elevations that would be in there are 596, 97, 98, 99, and 600. You look over here, 595 to 599. Same issue. You're only going to have 596, 97, 98, and 99. If we look down here, 599 to 648, we will have 640 in here. It's going to be closer to the 648, but it's going to be in there. So we cross that line. We do the same thing again. We look over here, no 640. 583 to 594, there's going to be no 640 in there. But between 594 and 648, we will have another 640. Same thing again. We look over here, no 640. It's going to be somewhere like in here. We could finish this off. If it wants to connect and not be a butt. So if you're going to find in this assignment, sometimes it likes to be a little butt. Oh, I got it to go. No, I didn't. So this is actually a good learning point. Sometimes it snaps to a weird point. You could Control Z to come back to your last point, and what we may want to do is just turn off our object snap. So now I could just go to wherever I want and end it. And then we start on our next contour. So we do spline again. It says use 20-foot contour lines. So we did 640. We're going to do 620 next. So 620 will fall somewhere in here. And then we look for the next one, which will end up being around here. End up being somewhere around here. End up being somewhere around here. Actually, that one should probably be a little more in, since this one goes down to 563. And similar again. You could just learn that hotkey, which is F3. You could see it in parentheses if you want to do that quicker. Finish that off. Push enter to finish it off. If you ever need to adjust these, like say you drew this over here and you're like, wait, that doesn't work, you could always move it back in at any point you drew. And then we'll do our next one, which is 600, which is going to be directly on this point since we know that's 600. It's going to be very close to 599, but not on it. It's going to be very close to 594, but not on it. And 600 will be somewhere in here. And cool. So now we have all of those. You're going to continue this throughout the entire drawing. When you're drawing this, you want to make sure this doesn't accidentally cross a line it shouldn't. So say this accidentally snapped out here to 599. This crosses a point that 600 does not fall on. You will lose points for this. To just exaggerate it, say it went like that. This point right here is not 600, nor is this point right here. This one down here is not 600. So you will lose points on that. You could always adjust it after the fact, and you may need to do it on certain points to do it. But you're essentially going to continue this, and it's going to end up doing some wonky stuff. So let's end up drawing the stream in, since it says there's a stream that goes from A600, A600, A600. So we have a stream starting here to F750, F750 to I900. Okay, so that's one stream. And then we have another stream that's D0. Okay. It goes to F750. So they both meet here, and then they go off together. We have those two streams. Now what the student presentation is going to tell you is that depending on certain geologic features of the land, you're going to have certain shapes to your contour lines, which I mentioned in this assignment. The V shapes, the U shapes, the M shapes. That's what we're talking about. So I'm going to show you a 400 contour line because it's not going to be like this circle, and because it'll go through this double stream, so I could show you what I mean by this M shape. So if we go back to our line, start a spline, 400 will be somewhere over here. And then it's going to come up here. This is rough, I'm just doing it quick. There, comes up, goes over. If we were just drawing this as is, you would have just drawn it, if you didn't have the stream, as something like this. But we're going to have to adjust this in a little bit because we know there's a stream there. So had you not known there's a stream here, you would draw this contour something along these lines. 400, 400, 400, 400, 400, 400, 400, 400. This is what it would look like. But we know there's a stream here. We're going to have to add in some extra points to kind of make this M shape, because what we know is that when you come to a stream, it points upstream in that U-ish V-ish shape, and then over here it does the same thing, which is how it ends up looking like an M. So we could adjust this line after the fact. We started drilling down here and we went this way. So if we wanted to add some points, we could do it by hovering over a point and saying add a fit point. The first thing I'm going to do is slightly exaggerate this over here. And then what I'm going to do is hover here and push add fit point. And you could see that I could add another point if I want. Or I could add another couple of points. So if I go to there and then I do another one, I'm just adding them. And then I could tailor this to do what I wanted. And then let's add another one. And that looks pretty solid. You can kind of see it gets that M shape. Kind of gets there. This is what I'm looking for. So if you gave me that original thing where it's just a U there, it's bad. I need to see that you're like, oh crap, there's a stream here. I know what to do about that. That's what I want. And you could see this line is still good. It never crosses a point that is not 400. So 400, 400, 400. It doesn't like double back on itself where it's something squirrely like that. And if there was, say, another spline, nope, that's not how you spell spline. If there was another spline, say a 420, that went from like here to here to here, and you had it do something like this, and it went off that way, these lines can't cross each other. So that's bad as well. So you got to make sure after you manipulate this to get your shape that it doesn't end up crossing a line that it shouldn't, and that it doesn't accidentally, like, say this is a 400 line, but it crossed this 437 area. It's all bad. You'll complete this entire assignment. If you need to change your line weight, you could display your line weight by typing in L weight, pushing OK, and it says to do index contours, which is every 100. So we can make those thicker, 600, 500, 400, 300. We don't have a 300. 359 is our lowest one. So you should have index contour lines of 6, 5, and 400. Use a 1 to 200 metric scale, and that's that. Assignment 9. Summary of presentations. I'm going to give 3 YouTube presentations. You guys are going to give 6 presentations. And there is a presentation from a former student on Civil 3D that I used to do for an alternate track. So I want you to summarize or highlight interesting points from each of these presentations. So it's essentially a check on that you watched it, you synthesized the material, you know what's happening. Each one of these summaries, I just want between 200 and 400 words. So if we look at like this section right here, that's 236 words. I'm essentially looking for like a half a page on each presentation. Slightly more is fine. So your entire document should end up being 2,000 to 4,000 words after you summarize all of these. But that's all I want with that. Put your name on it and just put it in one Word doc or Google document and send it to me. So you'll just have different sections. So it'll be like, this will be bolded and it'll say basic drafting in CAD. This will say locations and direction, so on and so forth, and just have a summary. That's all I'm looking for. And then assignment 10, BP33 is back again. Guess who's back? We're recreating this, but this time we're going to draw it in 3D. So first half of the class is going to end up being 2D, how we'll draw that. And then eventually we start to make 3D models. I want you to recreate this. The only thing you don't have to do is all these annotations. So top view, the actual dimensions, you don't have to dimension it. I just want this shape. And I want it in this position. So this isometric view. So it tells you that in the assignment, I believe. Isometric view. And the way you would do that is, here, let me just create a box for you. A 3D box. Whatever. Cancel. Let's get rid of this. Say we had this sweet ass box. It's probably the dopest box anyone has ever seen in the existence of boxes. And I want you to see that it's going to end up becoming a box. Right now, we have that. We're going to region it. We get a surface on it. We're going to extrude it. Give it some depth. Nice. We got a 3D box there. What you are going to do is your BP33. This defaults to top view. We don't want it in top view. We want it in an isometric. Southwest isometric. Conceptual. Boom. Make it a nice scale. That's probably like a 1:30-ish. Nope. 1:50? 1:100? Damn. Too small. Just whatever scale ends up fitting nicely to maximize it. For your assignment, I believe it's going to be a 2:1, if I remember correctly. Maybe a 1:1. Fill out your scale, have it in this, submit this DWG. That's what I'm looking for in this assignment. And that is all of your assignments. Just double checking because I don't want to make another video on this. It's already an hour long. Yeah, that looks good. That is all of the assignments. Please use this presentation to consult. If you have questions on it, if you need further clarification, feel free to ask questions, and I could help you out with that. But there are times I may not respond immediately, and this you could use as a resource for that.